Hello, hello, and welcome back to yet another stream where we will be continuing building our compiler. And for today, I have planned some nice stuff, like implementing diagnostics so we can report errors in a nicer way than just crash the program as we do right now. And yep, we also will introduce variables into our compiler, which I'm pretty excited about because variables are cool, and without variables, programming languages would just suck. So that's pretty cool. Yep, so let's get started with our diagnostics. So um, right now, if we have something like this, which obviously is not valid in our program because we don't have something like a bitwise AND or anything like that, what happens is that if we run this program, we see as an output that it's actually valid. Like not valid in that sense, but it is valid because the expression is just, our parser only parses up to here and then just stops if it encounters a bad token, for example. And we don't want that. We want an arrow saying this is a bad token, sorry, we cannot accept this program, and then terminate the compiler. And so that is what we are going to do now. And the first step to that is that we have to introduce a concept called diagnostics. And I'll put that into a separate module, actually. So with this, we're going to attach that to our project. Basically, a diagnostic is just a data structure that holds a message, like an error message, probably a text span, because we'll have to locate the diagnostics somewhere in our source code. And last but not least, we can also say that each diagnostic has a kind, like error and warning. So we can also emit the warnings, for example, if there is variable shadowing or something like that. Yep. So let's just create a constructor for that. All right. And so that's basically our infrastructure, our data structure for our diagnostic. And what you'll commonly see is that we'll have to have a shared place for error messages. Because if you just specify or like create a new message every time you encounter an error, you'll not have consistent error reporting, which might confuse your language users. So what I often do is I create something like a diagnostics spec, right? Which just holds a list of diagnostics. And this diagnostics spec is also need a constructor, right? And it will have basic methods. Like, for example, we can report an error here, which will take a message in a text span, obviously, and error as a diagnostic kind can be inferred here. And we also have a report warning method. And this diagnostics spec will be enhanced with all the error reporting methods that we need, like all the different types of errors that can occur. For example, what we can do right now is we can say we want a method like report unexpected token or something like that. So we say like expected will not be a string, but probably like a token kind, and token that we encountered will be a token, which will just make it easier to report stuff. So so we're not gonna put the token directly in here, but the kind. And we'll have to implement display for our token kind struct, So we're gonna do that really quick. For token kind, we'll implement this method and we'll say match. And will be number, will be plus, I guess. I mean, we could also say like this, minus that. All right, so now we can display all of we can display our diagnostics. Why do you not like that? Expected arguments. Oh, maybe we should use the macro. That would speed up things a bit. So nice. And now this should not throw an error anymore. Perfect. So now we have a diagnostics bag, and now we'll have to create one of those. So what you typically do with something like a diagnostics bag, which will be shared across many of our structs, like parser, lexer, later on type checker, and so on. And with something like that, you often run into problems with the borrow checker, because we'll need a mutable reference to our diagnostics bag to be able to report errors, because this takes a mutable reference to self. And we want this diagnostics bag to be shared across multiple different types. And in Rust, that can often lead to problems. So what you typically do is you do not directly have a diagnostics bag which lives on the stack, but rather you have a cell type which provides interior mutability, and you something like it could define a cell or a ref cell. In our case, we're going to use a ref cell, and together with that a reference count, because what a like RC is called in Rust, what that does is it drops the value once there are no references to it anymore. And that's exactly what we want, because it's shared across multiple structs, and once no struct holds a reference anymore, we just want to drop the value. So we say let diagnostics bag is equal to RC, which stands for reference count, and which will hold a ref cell, which will hold a diagnostics bag. And what I also like to do with all these RC ref cell types, I like to just define a type in here, something like up type diagnostics bag cell or something like that. So I don't have to type this every time I want to have the diagnostics bag in a struct. Exactly. So we can also annotate this here, just to be more consistent. And yep. So what can we do with that? We'll probably need to pass it to our parser. So this parser will need a diagnostics bag, which will be passed in a constructor. Right, and what we're doing here right now is we're just returning options, right? And if something fails, we just return that, which is also why our program is not parsed fully, and only like the part before the invalid token is parsed, because then it just returns none, and it only adds the statement to the AST until it returns none. So first step would be to remove all the options here, which will be quite a bit of work, I guess. Yeah, let's just do that real quick. And we'll have to remove all these question mark operators. We'll handle that later. So return option question mark operator go away, and Query operator. Actually, I think we're gonna keep that. We'll just have to handle. We won't because that's also already handled in here, so that's fine. We don't need the sum here. We can remove the option from our parse primary expression. That's gonna give us some errors. I see. Okay. Cool. So we have to remove that as well. Let's add a little to do. Add error, handle error. Okay, fine. So now that we also don't return options anymore, we probably don't want to return an option from our current method because that will just make things awkward. And like most of the time, we should not run into issues with that. Because what we can just say is in peak, we obviously can return the option because you can just specify any offset in here. But in current, we'll always pass 0. And essentially, we could also maybe even return a token here. I guess we could do that. And why is that? That's pretty simple actually, because we can just say let's extract this index, and if we make it mutable, and you can just say if index is greater or equal to the token length, we just set index to the last possible value. And with that, we'll never run into issues. And that's also kind of what we want, because we want to parse until we hit an end of file. And if our offset is too big, we'll just have an end of file token, because the last token or token array is always going to be a end of file token. So we can also remove this option here and also here. And so we can also remove this sum. And I guess we can already also place this. Cool. So now that we have done this, let's get into proper error handling. I guess we kind of want to keep the option here though, and return none if we are at the end of our program, which is indicated by our end of file token. So we can just create a little helper method here. Is at end exactly, and we just say if we're at the end of our program, we just return none. Else we return some, I guess, some with parse statement. Correct. Okay, that's cool. So we can also remove that from here. And we don't need that anymore. Cool. Exactly. So let me drink something real quick. Okay, nice. Already don't need that anymore. I will not compile. And I don't know why my cargo analysis is not enabled. We'll just turn it on really quick. And we're getting errors here. Okay, cool. So we don't need you, we don't need you. We have to remove the sum. That's actually bad here because we don't want to panic anymore when we encounter errors like that. And we'll fix that real quick with a method called consume and check, right? Which just takes a token kind, and we'll not panic here. But we should report an error here. Okay. We'll also return a reference to a token here. And we're just gonna say, okay, we'll handle that later. So, okay. And here we're gonna make use of our diagnostics pack. We're gonna borrow that and say report unexpected token. And we're gonna pass the kind. And we are gonna pass the reference to our token. So why do you not like me? Takes 3 arguments. No, of course. No, that's actually not what we want because we don't need the span here because the span is already included in our token. We can just say token span dot clone is clone for span. Yes, it is. I mean, that's not the best way to do that because actually you could probably share references here, but that would just make things a lot more difficult. And we just want to get started here. So that's working, that's pretty cool. And so this borrow method essentially just takes a, why does that even work? We're taking a immutable reference, but you need a mutable reference, right? Okay. So we'll need a immutable borrow here. So that just takes the value from within the cell and borrows it mutably, like normally, and gives you access to all of this. So, we can probably do the same thing here. We can just say we borrow our diagnostics back, borrow mute, and record an unexpected token. So what you can say here, I mean, we could probably just say record expected primary expected expression, but we got this. So let's just add this method to our diagnostics pack. Report expected expression found. Exactly, cool. And now we of course have to return an expression from that. But we could of course make something up, like we could say, okay, cool, we're just gonna say you'll be a number expression. I mean, that's kind of weird, right? So what you often do is you just have an error type, which will just indicate that there is an error and something wrong, and we'll probably need span as well later on. Check span. Cool. So we have this. Now we have to implement that, add that to our visitor. And that's gonna be text span. We're gonna put a visit error method. Visit error. And we'll not provide a default implementation for that. Okay, that's cool. So add that to our AC printer, which we'll probably even replace in the stream because it's not too good for debugging. Yep. So we now have an error expression. We have basic error reporting. Now we have to somehow print that, or these errors, right? And what I like to do is I like to have a separate struct for that called a diagnostics printer. This diagnostics printer will have a reference to something called a source text, and we'll implement that in a second, and also to our diagnostics. And we'll need the lifetime here as well. And that's cool. So let's just import diagnostic real quick. And before we do anything with our printer, we'll probably have to implement this source text struct. So let's create a new module called text, and we're gonna say mod attach the file and start. So we have a struct called source text, which will hold a owned version of our input, and we'll have a basic constructor. And now our source tag is basically just a wrapper around our input and just will provide cool methods like getting a line by index, getting a line count, like how many lines there are, line index of at a specific position and stuff like that. Yep. So I guess we can implement these methods on the go as we need them. If you like while we're implementing our diagnostics printer. Yep, let's do that. So we have an implementation for our diagnostics printer. Take a lifetime, and like as always, we'll just create a new constructor which takes a source text and diagnostics. And next up, we'll have a method called and stringify diagnostic. So we'll take a reference to self, a reference to a diagnostic, and it will return a result. Because there could go something wrong, probably, I guess. So let's do that. So what do we need, or like how does our output even how should our output even look like? I'm thinking of something like this. Yep, exactly. So I'm thinking of something like that. So yeah, I could have copied just yeah, it knows what I'm gonna say. So I'm thinking of something like this where we say, okay, we mark the arrow in red with like ASCII codes and stuff. And then we'll have something like Rust, like similar to Rust. We'll have like an arrow pointing to this arrow or to the location of the arrow. And it should look something like this. Actually, let me do that real quick. Up. Yep. I don't know if I think that's correct. Okay, it is. And here we'll have something like this, like an indented error message. Right, cool. And we'll also have line and column in here. So what do we need for that? We'll probably need a line index. We need to know what line we're in, because I don't know, do we want diagnostics to cover multiple lines? I think that would make sense actually. But I guess we can also do that later. And for now, just allow diagnostics for a single line. Yep, I guess that would make sense. For now, at least. So we'll need a method called line start, I guess. Or line index. I guess first of all, we'll need a line index. So a line index, self, and a position in the text. We'll return a use size. And we'll just take our text to this position and take lines and count. -1, nope. Actually, I don't think so. Because what would happen now if we have no lines? It should return 0, right? If we only have one line. And yeah. So now -1 here. So we can start by saying, okay, cool. I now have a line index. So that line index, and we just get the line index at our diagnostic start position. Now we'll also need the text at this line, right? So to do that, we will probably do something like, I don't know, fn get line, which take a reference to self, and index, and return a string. So we'll just say, yeah, probably something like this will make sense because we're just iterating over the lines, taking the line at index, and then unwrapping it, which seems a fine thing to do actually. So yeah, let's do that. So we'll now have now access to the line. We don't need that, I guess. And we could probably also just panic and not return a result here. Yep, I just panic. So now we need to know in which column the error is, and how can we find that out from a line index and our line? I mean, because we have the line, we have the length of the line, and I mean, I don't think we even need that, right? We just kind of need the line start, and do we need that? We have the line index. The problem is that the start in our span is a position relative to the whole file, right? So we need to know where our line starts to know in which column we are. So we have like that line start, self line start. We're gonna implement that method pretty soon, and we just say column is a span start minus line start because we just say, okay, for example, this is position for this is position 14, and our line start is at like, I don't know, 7. So this will really cut up 7 because we have to go 7 to the right. Right, okay, cool. And next up, well, like the idea that I have is that you display a certain amount of characters before the arrow and after it. So we'll have something like, I don't know, const prefix length, which could be 8 characters. Yeah, that seems reasonable. So our prefix would be like the 8 characters before X in this example. But we don't have 8 characters before that, so we have to check if the prefix length would be long enough. In this case, prefix would be 4 characters long. And how do we do that? We say that prefix, yeah, I guess. Yeah. Yeah. So we use compare to say, okay, we take our column minus our prefix length. I don't think that's quite correct, to be honest. We just say prefix. We could say prefix start, for example, which will be it's not max 0 max. Okay, we could say, yeah, I think that makes sense, to be honest. Because in this example, that would mean that we say we check a column which is 5. It's probably gonna be 4 because we're using 0 indexed positions. So a column will be 4 and prefix length will be 8. So this will be -4, and so this will just resolve into to 0, which is what we want. And we can also say like let span start is probably column, so it's not necessary. At prefix and yep, this will not be inclusive though. Fix start, yep. But we'll also have to check if that exceeds our line length, I guess. Yep, so we're gonna say comp max. Yep, that's correct, I guess. I mean, the problem is star will be inclusive. So we should probably add one here. Will that be a U size? I don't know. Probably. Hopefully at least. And we'll now have a suffix end, which will come from our start and our prefix length, obviously. And obviously we can also not exceed the line length here. So we have to do the same check here again. Oh, dramatic. Thank you for your follow. It's really nice. Hope you enjoyed the stream so far. And now we can create the actual prefix string, which will just be from prefix start to prefix end, and end will be exclusive. And our actual span is prefix end to suffix start. We could probably also just take the literal from the span that our diagnostic includes, but I guess, yeah, let's just do it like that. And we can say the suffix will be from suffix start to suffix end. And now we'll get to the cool part, because now we have to figure out how to print this arrow, let's call it. And that's actually pretty simple, to be honest, because we will just have to figure out the indent of this arrow, which basically is just the column. And then we'll have to print this arrow as many times as the arrow span is long. And we have to do the same for the arrow, the pointer, but we only have to print it one time. And then we also have to indent this message column times and just print the message. And line and column we already have, like line index plus 1 would be a line count, and column plus 1 would be a column count. So we just say our indent will be, what will our indent be? I mean, it will just be, it won't actually be a column, because for example, if our column is like 14, we don't want to indent 14 times, because we only print 8 characters, or like prefix length characters before that. So we want to say our indent would be something like this, which does not make too much sense, I guess, why would you do that, because it can never be less than 0. I think that's fine. So what we can do now is we can say our arrow pointers will be will be arrow pointers be, I guess we can say something like format. Then yeah, that's what I'm looking for. That's a pretty cool way of doing that, actually. And now have to specify get our arrow line as well, which will be something like that. Okay, cool. And I don't know if that's actually what we want. I guess the problem is that we don't we want to print this as many times as the span is long. So we have to specify that as well. And how do we do that? We say, is there something like a repeat method? I think it could be like in the iterator create, I don't know, something like repeat. Cool. That's actually cool. So we can probably just repeat a char here. And we just take, and we'll take that next explain length and collect that. Okay, cool. That is working. And now we have the arrow line, the arrow pointers, and now we just need the arrow message, I guess. I guess we'll do the same thing here again. Right? Yeah, I guess. Arrow message will just be a format that, and we'll have to take indent here as well. Yep, exactly. Cool. Now that should probably work. And now we're just gonna return format. Yep. And GitHub Copilot already read my mind again. Already read my mind again because we are gonna color this span because we like colors. Because colors are just cool, I guess. And we're gonna use the Termion crate for that. So we're gonna add that cargo add Termion, and I'm in the wrong directory. CD Fusion compile. Right, and now we are in our correct cargo directory. And with this, we can import this foreground function. Also import red and reset. And I guess we are missing stuff here. It's this prefix, red, span, reset, suffix, arrow pointers, arrow line, and we'll put another one for our arrow message. Okay, cool. So now we'll just have to implement the line start method in our text. And line start. And I guess we could do that. So we'll take index lines and map line length +1. I don't know if that is correct. I mean, I guess because we also have to include the skipped new line character. Yeah, it should be fine. Cool. So now we have a stringify diagnostics method, which is pretty cool. And we'll test it right now. So we just have to create like a method called print, yep, which will print just all the diagnostics. And we'll now have to pass that diagnostics back with rc clone, which just clones the reference count. and not the actual diagnostic back. So what we can do probably is before evaluating, we can say that diagnostics binding. Yeah, so if you have more than, or you have any diagnostics, we want to print them. And we'll also need to create text from our input. Exactly, cool. So the rest will just stay the same for now, which is fine. And why do we not have a printer here? Okay, I don't know. Let's just import it directly. Wait, is it not public? It is. Diagnostics printer, what? Okay. Maybe, it's not included in here. I don't know, public. Okay. That makes sense. So, diagnostics printer. And because we have an ampersand here, it should theoretically say that it is a bad token. So let's just see if that works. Nope, because we have to implement the visit arrow method in our evaluator. And we just have to do there for now. And there's also no structure for arrow. Maybe now? Nope. Okay, wait. Cannot borrow is immutable because it was also borrowed. Okay. Yep. I think I kind of see the problem. To be honest, I don't really know what we can do about it. Wait, we think. I guess because we're still taking a mutable reference to our consume methods. How can we do that? First of all, let's remove this panic because we don't want that. Let's replace it with a consume and check method. I guess what we could do is, because the only thing that we're mutating in our consume method is a count, right? And I mean, that's not that bad actually, I guess. I mean, we could replace that with a counter that just holds a value in a cell, so we have interior mutability without having to pass mutable references, which would make quite a lot of sense, I guess. So we'll just build a nice interface around that called a counter, I guess, because we only want to hold use sizes. Yep. So something like this. Oh, Frosty, thank you for your follow. Hope you're enjoying the stream. Yep, right. Cool. Thank you, GitHub Copilot. You're really on fire today. Cool. So our increment just takes our current value, gets it, and sets it again. Increment by 1. So we can now use this counter in our parser instead of direct use size. And we'll have to change this here, just counter new. And we could probably add some errors here because we're using current, just like with use size. We can just say get a value here. And instead of having a mutable reference here, we can just say self current increment, because increment now takes a immutable reference to our counter, and so we can use a immutable reference of the parser to consume our token. and we can also replace this here, and that will get rid. So now we got rid of our borrow checking issues because we now only have immutable references to our parser, at least in these current and peak and consume methods. So maybe our program will run now. Cool. And we're getting issue. Panic somewhere. Okay, that's not cool. You see that? This parsed as an arrow. Okay, that's good. It's progress. So why do we get an error here? I guess maybe our line index is not 0 index. Yep. I know. You should probably. Do you return? Wait, let's just set a breakpoint here and debug that. Like in theory, we should get a 0. Okay, we're getting a 1, which is actually kind of weird. Wait, is there some documentation here? Ended with your new line. Final line ending is optional. A string that ends with a final line ending will return the same lines as a data string without a final line ending. Okay, so I guess this will always. Oh, it should work. Oh, issues here, right? Count. So I guess we'll have to subtract 1 here. Maybe that will work. Yep, it did. Okay, cool. So you see that? We have 8 characters in front of our ampersand and only 2 after that because then the line ends. And this indenting also works. That's cool. And I guess we could make that a little bit more elegant in our printer because this function is pretty long. Actually, yep, we could extract this definitely. So we can just say like, I don't know, get text spans. Not the best name, I suppose. That's fine. And could also say something like format error. Yep, that's good. We could also say format error message. Yeah, I think that's good enough. I really like Rust formatting. By the way, Jesus Christ, you just have a bunch of curly braces in here. That's hilarious. Okay. Line. I guess we'll probably have to take a reference to self here. Yep, I will fix errors. Because now the lifetime is correct. Is it? No, may not live long enough. Okay. So we'll probably need a lifetime here. An explicit lifetime. And we also need to add this to self. Because our prefixes should live as long as self, I guess. Does that work? Oh. Or in the scope. Maybe we don't need to then. Does that work? It does. Okay, cool. Now everything works as expected. Very, very, very nice. So, now we have error reporting, which means that we can probably get 2 variables now, which I'm pretty excited about. So first, we have to think about a syntax for variables. I mean, I really like Rust syntax. So we could probably say something like, yeah, like this. You can let A is 10, let B 20, and then C can be A plus B. So variable declarations are started within that keyword. I guess before we do that, we can maybe spice up our AC printer visualizer a bit. And actually, right now we're printing just like this. Oh, actually, get an error here. Okay, we'll take a look at it later. But right now we're printing the AC like that, which is not that cool actually, because it's pretty large. You cannot really see things. Probably should also remove this token print statement. And because of that, what I would like to do is just try to replicate the input string that we got, but like with color highlighting and proper indentation and stuff like that. So a little bit like an IDE with a format, but like static. You cannot edit anything. So what we could do is we could just take this visitor, visualize AC printer, and we could go ahead and say, let's change it up a bit. So what we could do is we could say we probably don't even want to implement this. Also not this. We want to implement that. So what we want to do is we have a const number color, which will be color cyan maybe. Exactly. Why do you like me? Okay, we'll have to define it in a separate implementation block, I guess. Probably need a normal text color, which will just be, I guess, white for now. Yeah, that's it. Actually, we already have anything else. So what we'll do here is we'll say we'll need a kind of a result, I guess. Do you need an indent? I guess later on we'll need that. Right. Okay, so the result is a string, and we just say self result, and we push a new string. And we don't even need this value number. And that's it for our number. And error will just print this normal, I guess. Span the row. We could probably also create a method here, something like and add or push with color. Okay, that's pretty annoying because we can just do that. Okay, yeah, let's not do that. What we can do is something like add white space. Just add a white space here. And add something like new line probably. And we need white space, new line, and probably, do we need anything else for now? I don't think so. So let's just print this binary expression. And wait, why do we have values? Okay, we just need parentheses. So what we can do here is probably can visit an expression for left side. Then we can print our operator, but before that we need white space. Add white space. Wait, text. Okay, it's done. Add white space. We can visit the right side, but we need the operator in between. So we'll say let up. I mean, we could probably just stringify the kind because we have to implement the display for that. So push string. Okay. Or we could just take the literal. It's fine as well, I guess. Text color. Yeah, that's fine. Cool. So parenthesis size expression will just push parenthesis and the expression. Yeah, that's right. Okay, cool. I don't even know if we need the color. Yeah, we probably do. Do you have any other ongoing projects? Currently not really, or at least I'm not live streaming any other projects. I mean, I'm personally working on some AI stuff and like crypto trading bots, but it's more like a personal project. Yeah. And I mean, I've worked on some compilers in the past, but I've never really finished them to a whole. But that's definitely my goal with this one. I mean, I've always got to the point where I had like working function calls and stuff like that. I've even written a virtual machine in Rust for my first programming language that I've ever implemented. That was in Kotlin actually. And so I wanted to have like some more speed, and so I implemented a virtual machine. And lately I've been more into like assembly and stuff, and so the goal with this project definitely is to get to like generating real machine code. I don't know if we're gonna do it like directly by ourselves or if we're gonna use like LLVM. I guess we're gonna use LLVM because it just makes life a lot easier because we don't have to implement assembly for every single target that we wanna support. Feels like streaming stuff is a good way for staying concentrated, kind of debugging alone since you're explaining what you do. Yeah, definitely. I can totally agree with that. I mean, yeah, I'm talking to myself all the time when I'm coding, so it's not really that different for me. Because I can just really focus a lot more and find errors much more quickly, I guess. That's definitely a good way of staying concentrated, yes. Um, so where were you? Talking of staying concentrated and just getting completely distracted. No. I think we're done here actually. So now we can even remove this method because we don't need it anymore. And we can just try it out, right? I guess it's not gonna work because we've just written code that is just completely not supported by our language yet. So I guess we'll just go back to the old example, 7 plus, I don't know, 8 times 9. So we can try that. Okay, that does not work. Probably add a new method here. New Kubernetes constructor, new. Nice, okay. Let's try that again. And where, wait, what? We did not even print anything. Oh, because we'll probably have to print the result. And it did kind of work. We are highlighting numbers, but we're not resetting our ASCII color codes, I guess, because now our result is also colored cyan. And I think IntelliJ's theme is kind of messing with our colors because this is not cyan. Okay. So I guess what we have to do is we have to reset the color after each statement. So in our visit statement method, we'll probably have to say self.result push string. No, not let. Have to reset here. Yeah. So I think now we should not end up with our whole terminal color like the last thing we printed. But we'll need to call this now. Yeah, I think that would be fine, right? Actually is not. Oh. Maybe we should call that after we actually did the visit. Yeah, okay, cool. So in what line of computer science do you work? And yeah, okay, first message first. Yeah, low level is super interesting. I've started Rust recently specifically for that. Why don't you try producing computer architecture with code? Yeah, I feel like Rust is a good choice for that. I mean, I guess if you like really, really want to understand computers and really want to work on like low level stuff, I guess you could even go with C because Rust is low level, but it abstracts like many things away. You like you rarely, I don't know, you rarely ever run into like segmentation faults and stuff like that, and you don't really. I mean, Rust prevents you from doing bad things that you would do in C, and I think that's kind of part of the learning process that you just run into these issues, and you will have to Google up and find out how to solve these issues. And with Rust, it's like, okay, I'll just try stuff until board checker let me compile my program. And I guess C just get a little bit more low level, in my opinion. But I really like Rust. I think it's pretty great. In what line of computer science do you work? I actually am a computer science student right now, and I study at the Technical University of Munich. And as a side job, I work in a little startup in my hometown, which is pretty cool because we're not that big, and I get to do a lot of cool stuff. So, what is your opinion on like Rust, C, or low-level programming languages in general? And how do you feel about having control over everything you do in Rust compared to C and stuff like that? And I don't know if you've heard of Zig. I've actually wanted to try that one out because it sounds pretty cool actually. Because it's like much safer than C, but you still have like much more freedom than in Rust because you can still do unsafe stuff, and it's a little bit more like C. I think it's like a balance between C and Rust, I guess, which sounds pretty interesting. I don't know. Maybe I'll just write another compiler in Zig. Yeah, we'll see about that. Okay, now we have color highlighting working, and I guess now it should finally be time for variables. So let's just get our old example back again. Thank you, GitHub Copilot. So what do we need? I think we first need to start in our lexer because we need to parse our let keyword and our equals token, I guess, and probably even identifiers. Yep. So we'll need like let identifier should take string and equals. And we should probably get a little bit more structure in here. So let identifier and equals just equals. Correct. Thank you, good Copilot once again. Consume punctuation. We should add our equals here, so we exit. Do we actually, what do we do with identifiers right now? Nothing, right? They're just completely forbidden. Okay, cool. So we'll have to implement a method that is identifier start. Is alphabetic, cool. So check else if is identifier start. We can say let identifier consume identifier. Yep, that's correct. Now we'll have to implement a method called consume identifier. Looks correct. Replace that with a method call. Cool. And now we can't just directly say that the kind is gonna be an identifier because we have to check if the identifier might be a reserved keyword. So what we can do is we can say match, or we can say kind is equal to match identifier. Probably need a reference here. And yep, if it's let, then we just say token let, else token. Just say it's gonna be an identifier. Expected string font string string. Okay, cool. That works. Okay, oh, nice. I'm still a student too in Paris and working in a company as an apprentice. Oh, cool. What company do you work in? Is it a big one or also just a little startup? Like where I work. I actually started coding with C, which is a great way of learning computer science thanks to like 6 faults, make me understand how memory, a heap, and sec. Yeah, that's tough. Sometimes, really. I mean, I don't know how many of those errors I would run into if I coded in C. I mean, I don't know. Often I just try to pass references to stack variables, stack allocated variables around, and Rust just wouldn't let me because it just doesn't make any sense. Yeah. Toughy though with Sally, since I started working at a company, since I mainly code in Python and at school right now, our projects are mainly web-based, which I don't like too much. So I've been working on a lot of stuff on the side. Yeah, see if you start with C, you can learn any language after that. Yeah, sure. I mean, I started with Java, I guess, back in 9th grade. And yeah, I mean, ever since I started university, I really got interested in a lot of stuff because we also had one lecture, like introduction to computer architecture, and it was like really interesting. We've worked with we worked with assembly and stuff like that, and I don't know, it just yeah. I really started to show interest in that, and so I kind of started doing or looking around what projects I could do to like get a little bit more into that stuff. And I figured that, like I first started implementing my own operating system, which I don't know, quickly just stopped. It was interesting, but it was pretty hard because operating systems are a little bit weird sometimes. And so I got into compilers, and I mean, ever since that, I just yeah coded compilers and looked up some algorithms and stuff like that. It was pretty cool. I like compilers, and that's why I'm coding one right now. Yeah, That's basically like my story of why I am coding a compiler right now. And yeah, Python. I mean, I've never really used Python. I don't know. I don't know why I never used Python. I guess I'm using Python right now for my trading bot, but only because the other dude I'm working on, yeah, like coding with, I don't know, is not that much of an experienced programmer, so he likes to use Python, and so I have to choose. That's fine. Python is okay. I don't like it, but you can work with it, I guess. And I mean, at my startup, I also do a lot of work towards like web development, which is pretty okay. I mean, I also like developing front end applications. Yeah, I mainly work with TypeScript, which is pretty okay. I like TypeScript. You can work with it, but right now I like low level languages a little bit more. Like 22, 30 employees. Yeah, it's pretty, still a pretty small, not pretty small, but rather small startup. Yeah, we're like 15 people, I guess. It's pretty cool because you get a lot of like more important tasks or tickets compared to like bigger companies where you just get to do like really yeah work stuff, I guess. So, where were we? I guess we have to continue our journey on implementing variables. I think we're lexing now. I guess that should work. You can just try that out. What our arrows say. Expected expression found equals. Okay, something is not quite right here. Okay, so we're not adding any space here. And by index 22 is out of bounds. It's probably gonna be our suffix start, right? Okay, that's interesting. Oh, no, that doesn't make any sense. But okay, that makes sense. Because we're adding one here, our suffix start can be actually out of bounds. Because we're taking a line length, like minimum, and we're adding one, so it's out of bounds. I guess even if we didn't say +1, it could also be out of bounds. Actually not, because it's exclusive here in the range operator. So I guess we could just remove that. Maybe we will not run into that error now. Yeah, we don't. Okay, cool. Expected expression, found that one. Okay. I don't know, the indenting is kind of weird. Why? Why? Oh, probably because we have white space here. Okay, that makes sense. Yeah, maybe we could try to ignore that. I think it's fine for now. Okay, our error reporting works. Our printing, I don't think that is quite what it's supposed to look like, but that's okay. Yes, yeah, and you can work on more stuff. I feel like since teams are smaller and less specified. Yeah, definitely. I mean, I'm involved in like 3 or 4 different projects, which is pretty cool. I mean, you get to see a lot of new stuff and you get a lot more responsibility. Yeah, it's pretty cool. I mean, I'm working on a mobile app, a web app, and even some more AI-based stuff. It's pretty wide range. Now, let's get into parsing our variable declarations. So right now we just say whenever we try to parse a statement, we just parse a expression directly, which is not quite correct. What we actually have to say is we will match our current token kind And okay, that's not what I wanted. And we say if our token kind is let, then we'll know we have to parse a let statement or like variable declaration. And like otherwise, we can parse an expression statement, which would be this code. So we can say parse expression statement, which will take a mutable reference to self, return a C statement, or we just return the code that we just had. Cool. And now we have to parse a let statement. Before that, we probably have to add it to our statement kind enum and create a struct for that. Guess we'll have an identifier token and an initializer expression. And we should probably also add a constructor for that. Cool. And now we're ready to do actual parsing, I guess. So we can say parse let statement, take mutable reference, turn a C statement. So we can say stuff consume check token kind let identifier consume check identifier. Yeah, that's pretty. I don't know what you can do about that in Rust. I always run into that problem because now I have to specify some string here, which will break things. So I guess we'll have to change that. We pass an identifier here. So we'll just not pass any value here. Just say it's an identifier, and you can get the value from our text span, actually. I guess, yeah, that would make a little more sense. And we can expect an equals token here. And then we're gonna parse an expression. Identifier token. So we have to clone this. Okay. Cool. Now we're parsing a let statement. And we'll probably have to add a little bit of code to our different match statements. And you don't like me? Okay. Main. So, Frosty, are you also interested in compilers yourself? Like, do you ever plan on building one yourself? Or are you just interested in some other low-level programming stuff, like, I don't know, building an OS, programming an embedded device? I don't know. What do you do? Let's say that. Segment. So we have to implement this method in our visitor. And we'll probably also have to patch a new line here. So we don't end up with just a bunch of squashed, weird, I don't know, stuff. So we're gonna format let let, so using parentheses, white space, we'll say, okay, we'll need our I actually don't like we're using text color here. We could use something like a keyword color. I want that to be green, like magenta, I guess. So we're gonna use a keyword color here. Keyword color. Oh. Okay. Auto completion not working. It's equal to. I'm doing that wrong, right? Yeah, it needs to be the other way around. So you can remove that, and now we can add white space once again and visit the expression. Cool. Maybe that will work. Oh, wait, to implement this in our evaluator as well. Yeah, we're just gonna do the thing there for now. Cannot borrow. No. Or does consume check still taking? No, it does not. Wait. Why? We're mad. Because it is already. Oh. Oh. So we're just going here. Cool. So that is working. See that? Good. Color highlighting. That's pretty cool, in my opinion. Now we just have to pass these variables. So compilers. Never really thought about them that much. Not something I'm keen on working on. But right now, my main project I'm working on is like a shell phishing project. So basically, like either automatically setting up a shell with configuration on your computer, installing all languages, compilers, machines need, etc. And long term, maybe I try to do like shell mirroring, which isn't really low level, but I've been getting into S and stuff recently. Don't know why. Yeah, yeah, shell mirroring is pretty interesting, I guess. Yeah, it's a cool project. I mean, like shell phishing projects. So basically, you just say, okay, cool, this is my program. My program can set up your terminal with all the tools that you need. So like Python, interpreter, C compiler, and stuff like that. I mean, that's actually pretty cool. I mean, that's something you probably need, yeah, and that's also something you could enhance on a like company level. So you could say, okay, cool, this is my company. My company's employees all need this tool installed in their system. So you can like dynamically maybe configure that. So you can say, yeah, my everybody in my team needs Vim installed because we're geeks. I don't know. And so you add that to your config file, and now everybody has Vim installed, which will be pretty cool. I don't know. Yeah, and OS is cool, I guess. It's also hard. I mean, I think I'll have a lecture on OSs next semester, so that's probably where I'll get into it a little more. And, I mean, yeah, I'm excited. I'm excited, and yeah, probably. I don't know. Maybe it's gonna be cool. Maybe it's just gonna be whack. We'll see. But now we'll have to parse variable expressions because declaring variables is cool, but if we can't use them afterwards, that's pretty whack. And I think we're missing our identifier here, which isn't good as well. So we'll have to push our identifier token. Maybe that works out. Cool. Now we also get these identifiers. So we have to parse these, and these are gonna be primary expressions once again, I suppose. Parse primary expression. Yeah, exactly. We're gonna have identifier with a token. Okay. Should probably also add the identifier name as a field to struct to make our lives a little easier. So variable, I guess. Just gonna take an assume variable expression and derive debug. Do we need debug? I don't know. See variable expression, identify token. Yeah. It's good to create a quick method. Identifier. Just gonna return a string size. Cool. Match that and like visit variable expression. It's not gonna have a default implementation. I'm gonna rename that to visit expression, just to be a little bit more consistent. And I guess we'll also not have default implementations for those, because that could just lead to errors. So with a variable expression, cool. And now we have to implement our parser. We're not text color. Variable color. Forward string. Wait, do we? Okay, so we did that everywhere. I mean, that's fine. Variable color is gonna be green. Yeah. Maybe we're just gonna change that to light white, because that's pretty dark white actually. Wait, does that work? Nope. Okay. We need an identifier constructor here. Identifier. Just gonna take a token. Okay. Did I misspell that once again? Yep. Identifier. Okay, compile. Nice. And panic not implemented, but it is highlighted as green now. Cool. And our text is a little bit more brighter, which is cool. So yeah, it was pretty weird at first for me because there's a lot to learn and it can seem pretty overwhelming. But since I mainly work on Ubuntu now, it's been getting pretty fun to get to know the machine better. Yeah, that's true. I think I recently tried to build like a Linux executable from scratch. Like basically just doing syscalls. And that was pretty interesting because I've worked directly with assembly. Yeah, I even tried to like get to work on my own memory allocator so I could do stuff on the heap. Did not work out very well. I ran into segmentation faults a lot and didn't continue ever since. But maybe in the future. It was pretty cool. I got Hello World working with the right syscall and like a file descriptor set to -1 or 1, something like that. It was cool. Yeah. I mean, we now can try to implement like variables into our evaluator, which is not that hard at this stage because we can just say, okay, cool. We have a hash map on variables. index, like index by string with their name. We can just say last value is gone, last value, and variable is just going to be hash map, new hash map. And when we visit our next statement, we just visit the initializer expression and then just set the value of the variable to the last value that we have evaluated. So we have to change that up to initialize. Let's say man identifier clone. Wait, why do you not work? Okay, identifier span 0. Cool. And now whenever we visit a variable expression, we just have to get the value that was stored inside this variable's hash map. Yep. Okay. Cool. Visit expression. Yep. Fine. Yeah. Now we should see a result of 30. Nice. That's pretty cool. So we get like 30 here, we should get 60. And we do. And that is pretty cool. Maybe we can even like add our D is like 10 and we can just multiply that with D, which should get us to 600, right? My math isn't too bad. Cool. It's working. So we now have working variables. The problem is right now we don't validate that a variable exists, so we could say something like this. And yeah, we're gonna run into issues because we try to unwrap a value that is not there, which generally doesn't work because you can just get something out of nothing. So I'm thinking right now, will I end the stream now or will I implement like checking if a variable exists? I mean, it's not that complicated actually. I think we could maybe even, yeah, won't take too long. I guess we can do that. We can do a basic version and improve that in the next stream, I guess. Because it gets a little bit more complicated when you add like different scopes and stuff. We can like say something like this, and here's a new scope, or even declare like functions, something like this. Because in here you like if I declare a variable in here, then you don't have access to the variables. I mean, you don't have access to D out here if you didn't declare it yourself. For now, we have access to every variable everywhere because we don't have any scopes. We just have one scope. And I guess we can just build a quick AST traveler that just checks if the variable was declared before it was used. And we can do that. Let's just do that real quick. How do we do that? We'll create an... I could just create it in here. Yeah, let's just do that. So we just say like struct symbol checker. I don't know. Yeah, something like that. Let's see visitor symbol checker. I mean, that's just a pretty bad implementation that we're doing here. If we visit a that statement, we just insert symbols. Just take our identifier. Oh, you public, right? Okay, that's bad. Identifier, span, literal, clone. Now in our variable expression, we would probably need a diagnostics back. We do not contain the identifier. Expected string from string. Okay. To string. But okay. So then we'll just say this is binding. Report undeclared variable. And we'll pass a token. Make it public as well. Or undeclared variable. And here we'll just do nothing. Okay, create here. No, okay. Does undefined work? What do you mean? We do not have any kind of undefined in our language right now. The only type that we have right now is an integer. Yeah, so every variable has to be initialized for now. We can change that later, I guess. And we don't even have any type checking yet, which makes sense because we only have one type. Yeah. But we'll need to implement this reporting and report undeclared variable. Token, undeclared variable, token kind. We're not gonna do that like this. We're gonna say declared variable. And then we're gonna take span, literal, fine. Okay, cool. Okay, why do you not like us? Reference. I guess we could even now check. Extract that and say check diagnostics, which could then return a result. We could propagate with the question mark operator, and now our main has to return result itself. And we return okay here. We return error here. We return okay here. And let symbol checker. That's fine for now. Borrow off move value. Oh. Maybe we should take a reference. Symbol check. Okay, we have to tell you it's mutable. Check diagnostics. Okay, cool. Yeah, we're not that far yet. It's like the second stream. But yeah, I'd really appreciate if you checked out the YouTube video. Be cool. And I mean, I'm pretty open for suggestions on what I could do better because I've never really done that before. And I just thought, why not stream when I code? Maybe some people like to watch, and I can finally talk to myself without feeling like totally weird. Yeah. I mean, we'll get into type checking and stuff like that next stream, I guess. I don't know if we should do like control flow stuff first or type checking. I mean, I think type checking would make more sense because control flow also requires Boolean values, Boolean types. So I guess we'll do that next stream. Like, type checking and creating a typed AST. So basically every node in the AST gets a type. And I'm not sure. I don't think we're gonna implement some crazy algorithm like algorithm W, which is based on like Hildney-Milner, I think it's called. Which, like that's the type inferring. Yeah, I think so. Algorithm that Rust uses for type inference, which is pretty powerful. But we don't really need that because that's more useful for languages that have like complex types like generics and stuff like that. And we do not have that right now. So we don't need that. And we can make our lives a little bit simpler. Oh, let's see if we get an error. We don't. That's bad. Okay. Why not? I mean, we should declare a variable. It's undeclared, right? I should report that. Or did I remove that? No, I did not. Why? Please tell me. Why did it not work? I don't know how contains works. Should work, right? Oh, maybe it does not work with strings. Maybe we could just use a hash map, I guess. Hash map, not text span, like just void. Symbols, like, we don't need a back here, just a hash map. Cool. It is none, right? It's not working now. Maybe we should also just implement a constructor for good measure. Please work. Okay. Why didn't it work? Yeah, I do have this as a repository on GitHub. I think it's still linked in the first YouTube video. I mean, you can get your link right now. I guess. I guess I do. I guess I do. Help. I just don't want to hear my own stream. So. Nope. Help. Oh, wait, what? I think I've just cleared my whole chat. Okay. Yep. Here you go. This link. I have not pushed yet, so changes are not there yet. We'll do that after the stream. Yeah, I don't know what I did. I was okay. Pretty newbie at Twitch, I guess. So, why does this not work? Do we ever get here? That's a question. We should, right? just set a breakpoint. We do not. Wait, what? We never get to this point? Okay. Which does not make any sense because we definitely have variable expressions here because they are highlighted. Oh, I see. Okay, I mean, we should probably just implement these by default once again because that just confused me really hard. I mean, we just did not visit the expressions in the binary expression, and because the variable expressions are like in the binary expression, they were not visited. And now we should get an error. We still do not get an error. Okay, so now I'm generally confused as of why this does not work. Ow, because we're not visiting the expression in the initializer now let's and that's exactly where we're using the undeclared variable. Please work now. Thank you. Undeclared variable e. Cool. And nice. That's pretty cool. I like that. So let's try one more thing. Like just randomly saying 10 plus a. Cool. That works. And please don't break everything if I just say this. Expected expression found bad. It's actually pretty funny that it just processes everything as a separate statement. It's just like 10% A. Like, what? Okay, that's cool. So, I don't know. Can you count that as a like kind of a formatter, right? Because if I put in something like this, it will format and put spaces in here. I don't know if that's how a formatter works. If it does, it's pretty cool. So we just implemented a basic formatter for our programming language. Nice. So what got you into working on a compiler though? Yeah, I don't know. I mean, like kind of being interested in low level stuff and like how everything works. I mean, I've been programming for 3 years now, I think 3 or 4 years, and I always took like programming languages for granted, and I just wanted to know how they work. And I found some pretty cool tutorials by Imo Landwith, I guess, was who got me into building my first compiler. Yeah, he has a pretty cool YouTube series. And I don't know, I guess it's just super fun. Like the whole concept of having just strings, it's just this string which is basically like just bytes somewhere stored in some weird RAM, and this gets like transferred to so many stages, like type checking, symbol gathering, like you have to gather function symbols, and then you have to lower these high level concepts like if statements and stuff to instructions that a machine can understand, and it's just so complex, but I don't know, so beautiful in its own way. And yeah, I mean, we'll we'll get into that. We'll get into lowering stuff to instructions that a machine can actually understand, away from all these if statements to something like a conditional go to or jump instruction and stuff like that. And I'm pretty excited about that. Yeah, I mean, compilers are cool. I guess you should definitely try it. You told me you tried assembly, yeah. In what context exactly? I mean, I've written assembly in university, and I've never directly written a compiler that emits assembly. At least not on a direct path. I mean, I've written a compiler which uses LLVM as a backend, which then is transformed into assembly, but not by me, but like by the LLVM compiler. So in some way, I've written assembly. Yeah, yeah. I don't know. Cool. But so now we are basically a formatter, and the stream is almost 2 hours long, which is pretty cool, just like the last stream. Um. So, oh, yeah. Fuck. I kind of forgot to like set markers in the stream because I kind of wanted to like add these different sections to my YouTube video so you can navigate through them a little bit easier. Like first part would be adding diagnostics and stuff like that. So I installed a script for OBS which lets me add markers to my recordings or streams. Yeah, and I kind of forgot to press the hotkey. Just functional testing in Haskell. Yeah, okay. I don't know. I think I'd regret that as well. I think, yeah, next semester, I think I'll have a, yeah, I'll have a course called functional programming. I don't know if we'll use Haskell. I don't even know what the other option would be. But I think it's a lot worse than Haskell. I don't know. I've never really used functional programming languages, so I'm kind of, yeah. I don't. I don't know if you. I'm excited. I mean, kind of. I'm interested in how these languages work. Yeah, I don't know. It's not just about functional programming. It's like I think 50% is just functional programming stuff, theory and so on, and then the other 50% are like verification, where we'll like learn actual ways to show that our program works as intended and stuff like that. I don't know if that's I don't know if I'm excited for that. Maybe we'll see. Yeah, I can't say too much about functional programming if it's like weird and stuff. I mean, I've seen some snippets, especially when reading up on this Holdney Milner, I think it's called. I don't remember exactly algorithm because that's used by almost every popular functional programming language. Like it's used by Haskell, and yeah, I think algorithm is really important for these languages. Not so much for like non-functional programming languages, which can still use it because it's still pretty powerful. Yeah. Hmm. Amazing for parsing. Yeah. So essentially, what a compiler does. Yeah, maybe next year I'll write a compiler in Haskell. Yeah, I don't think that's gonna happen to be honest. Yeah, I mean, I like Rust, so I don't think I'll write a compiler in any other language than Rust in the future. Well, maybe. I think there's some course at university, like I think it's Introduction to Compiler Building. Maybe I'll take that. We're not going to use Rust in that because, yeah, it's university and we're like lacking 5 years behind modern technology. So we're using C. Of course, we're using C. as if our professor would like to learn Rust. Yeah, I don't think so. Yeah, yeah. Maybe let's see. Maybe we can convince him to let us use Rust. So it's getting late. So if you don't have any more questions or nothing left to say really, then I guess I'll just end the stream and see you next time. I guess. Yeah, I'll upload the recording to YouTube. I think tomorrow, so you can rewatch it if you want. And yeah, in the meantime, you can just watch the last stream. It's even as I think I even enabled VOD saving on Twitch, but I think the quality might be better in YouTube. Yeah. Yeah, cool. I think you might have a harder time following the YouTube video though, because I don't know, it's just 2 hours of me coding stuff without any interaction towards you, and the font size was kind of small. I've realized that after the stream. So now I set the font size to like 16, I think. And before that, it was 12 or 13, which is fine for me, but it's pretty small in the stream, especially if you're watching like a mobile phone or something. It's like not see anything. Yeah, I don't know. You'll see. So what I can do is I can like write a checklist for what we want to do on the next stream. This is a was a checklist for this stream. We have added support for let statements. We have added error reporting, but we have not added if statements. So I don't know. What do you say? Should we implement like more types in the next stream and actual type checking, or like control flow stuff first? Mm, like while loops, if statements, something like that. I don't know. What do you say? Yo, my automod bot, I don't know, like he does not want you to send those messages for swearing. It's hilarious. Okay. If statements. Okay, we're gonna do if statements then, I guess. Hmm. I would mean that we'll also have to add like scoping if we wanted to, because when we declare variable in here like a, we don't want it to be accessible outside of here, right? We could do that probably. Yeah, then we could just do statements without any type checking. While seems easier than if statements. I don't know. I think it's like the same. Actually, I mean, in both you have a condition, and if statement you just say, okay, cool. If the condition is true, we execute the body here one time in a while loop just until the condition is not true anymore. So I'd say while loops are even harder. Might be even harder, yeah. I mean, you have else statements here, which might be kind of tricky. Yeah, I think comparable, like, difficult wise. Scoping, yeah, scoping can be hard. Like basic scoping is not as difficult, but once you get into like variable shadowing, stuff like that, and having multiple functions and trying to gather symbols for all of that where you can have duplicate identifiers which can override each other if you use like plain strings as keys, then it gets complicated. Yep. So we can say that was today. And so for next stream, yeah, we're gonna add if statements. So something like this. Else, sure, why not? I don't know if we'll add mute here. I guess we'll just have mutability by default for now. I don't like that. I really like Rust's approach to immutability first. But yeah, no, let's not do that right now. So add if statements and add while loops. Sure, I'm gonna add while loops, no for loops for now. Add scoping. So we're gonna add block statements like this at scoping. Okay. Cool. I think it's a plan. Cool. So I guess I'll see you next time. I'll probably stream tomorrow, I guess, in the evening. Yeah. So tomorrow evening we'll implement if statements, while loops, and add scoping. Yeah, you're gonna see tomorrow. I'm not gonna spoiler that now. Yeah. So you guys have a great evening, and I'll see you tomorrow, hopefully. And check out my YouTube channel if you like. Bye.